So, I asked you to have a go at this question here, and let's stop the clock and let's see how people are doing. So, quite a mixture of answers there. There's no one overriding answer. So then let's see what we got going on here. So this is a two-step problem. You don't know that initially. Do you ever do those problems, those like puzzles when you were a kid, where you'd have like 5 different routes and they all snaked around each other, and then here's the den that you got to get to, and only one of them goes there, and you know, your older brother or sister would come along and race you with it, and they'd always win because they could do it better than you can. And do you know what the cheat was? What was the cheat to find the route that you should take? If only one of them goes to the den. Did you guys not know this? You go to the den and you work your way backwards. And then you just pick that route, you know. If only one of them goes to the den, rather than picking any of the 5, pick from the den and go backwards, and you know how to begin. It's the same thing with physics problems. Always try and solve things in one step if you can. If you can't solve it in one step, you'll find out what you need to find out to get that one step. So it could be a 2-step, even a 3-step problem. It tells you what to do next. If you try to guess how to begin, you will do a lot of good physics and end up on the wrong path. And you'll have right answers, but they won't be relevant to what we're trying to figure out. So try to solve things in one step. So the first thing we do is we visualize, and we say, okay, so here's this thing being fired 40 degrees, looks like that. This here is going to be 25 meters per second, and this is 40 degrees. And it wants to know the range, so I want to know that distance there. And that's kind of all I'm given, so fair enough. Find R using HOR info. Well, I know that my VI is equal to, it's going to be 25 cosine 40 meters per second. I know my A is going to equal 0 meters per second squared. And I want to find my delta x. Delta x equals R, which equals I don't know. And there's 2 other things that I can try to find. VF equals, or delta T equals. And it's not clear to me which one I need to try to find, but here's with a little bit of thought. I actually know VF already horizontally, don't I? Because if the acceleration's 0, then VF is equal to 25 cosine 40, just the same. And here's the rub. If you think about your equations, delta VF squared equals VI squared plus 2A delta X, that's not going to work, because the thing I want to find, which is delta X, is multiplied by A, which is 0. If you multiply the thing you want by 0, it goes away. So all it says is VF squared is equal to VI squared, which we knew. So that didn't help. And then I guess the other thing I could do is I could say VF is equal to 1/2, delta X is equal to 1/2 VF plus VI. I need delta T for that. I'm sorry. I need delta T for that. If I say delta X is equal to VI delta T plus 1/2 A delta T squared, I need delta T for that. And the third equation is VF equals VI plus A delta T, and that doesn't even contain what I want. So I've got to find delta T. Okay. I mean, the direct way didn't work. So I got to find delta T. So I say, okay, find delta T using, and I've already used up my X information, so let's do our vertical information. So I say, well, vertically VI is equal to 25 sine 40 meters per second. And V at A is equal to minus 10 meters per second squared. I'm trying to find delta T. And I need one more thing. And that could be the Y displacement, could be my final time. I don't know what the height is, so I can't start my journey here and end it here. If I start it and end it at the base, my Y displacement will equal 0. But the almost obvious way to do it is you say final velocity, VF. You have two choices. Remember, I'm looking at the shadow. The shadow goes up and comes down. I could start my journey here and end it at the top, because I know the velocity at the top is 0. But I have to remember that this is only half my journey, and it's a symmetrical journey. So I've got to double that time, because I want the time for the entire journey. Or the alternative is I say I start my journey there and I end my journey next to it. Fell back down again, the shadow. The entire projectile journey is that shadow going up and coming back down. And I know for that it's minus 25 sine 40 meters per second. So I can say, oh, let's have a look at this. VF is equal to VI plus A delta T. Some people are not comfortable dealing with trig functions any longer than they have to. With more practice, you don't mind so much, but there's nothing wrong with at the beginning turning around and saying that's 25 cosine 40 and saying that's 19.15. It's positive. And turning round and saying that's minus 19.15 meters per second. There's nothing wrong with that, as long as you don't round too much. If you round to 20, you're going to not get the same answer as me, and that's going to upset me. So, yes.
You did cosine, supposed to be sine.
Oh, did I? Bad, Bonaquisti. 25 sine 40. You are right. Thank you ever so much. Let's just get rid of that, thank you, because that would have been embarrassing at the end. So, and just goes to show, it's kind of like I've done this for 20 years and you still make mistakes. So, when you're first beginning, really try to slow down and do it right. 16.07 and minus 16.07. Good. So let's shove it in here. So we go minus 16.07 is equal to plus 16.07 plus A minus 10 times delta T. So that means that minus 32.14 is equal to minus 10 times delta T. So delta T is going to equal, take that to the side, 3.214 seconds. Agreed? Let's change colour pen. Let's go to black. Substitute that substitute that into where did I put that first equation? Oh, I didn't do the first equation, so substitute that into here somewhere. Let's continue this. So this is going to be delta x is equal to VI delta t plus 1/2 A delta t squared. I'm sorry, I should have done that before I went off down here. So delta x is equal to VI, which is 25 cosine 40, 25 cosine 40 times 3.214 plus 1/2 times times 0 horizontal direction times delta t squared. That goes away. So this equals, so I take my 25 cosine 40 and I multiply it by 3.214, and I'm getting 61.55, 61.6. There's my answer. It's positive, meaning it's going to the right, which is where I drew my diagram. So can you see that this is a multi-step problem? This is where we want to be, and you can try and remember how to do this, but the better way is you say, what do I want to find out? Oh, I want to find out my horizontal range in this case. Let's try and solve it. Oh, I can't solve it because I don't have time. Let's find time using vertical information. Oh, I found time. Let's substitute back in. And that's the way it goes. Cool. Colored pens really help. Laying things out really helps. A diagram, I think, is essential. I think that if you don't have a diagram, you're gonna make missteps, but that's your choice. I mean, ball is kicked from the edge of a cliff with a speed of 12 meters per second. So now we have a cliff. So this is 12 meters per second. And this is 40. Elevation above the horizontal. Cliff is 2 meters high. Horizontal displacement. So again, it's a range thing. Just use different language for it. Should be same problem, but it's not the same. I'll go through this. I want to go through this. Find R using hor info. So I'm going to say VI is equal to 12 cosine 40, and I'm going to make that into a number immediately. So that's going to be 12 cosine 40, and that's going to be 9.19. And A is equal to 0 meters per second squared. And then delta X is what I want to find. That's R, which is equal to I don't know. And I've done this before, so I know I want to find delta T. At least that's where I'm going to head off to begin with. I'm going to say delta X is equal to VI delta T plus 1/2 A delta T squared. I'm going to try and substitute in, well, I'm going to substitute as far as I can and say delta X is equal to 9.19 times delta T plus 1/2 times minus 10. Sorry, I'm doing horizontal, aren't I? 1/2 times 0 times delta T squared. Oh, that goes away. So delta X is equal to 9.19 times delta T. If only I knew delta T. So yeah, change your color of pen. Let's do something blue. Find delta T using vert info. So I go VI is equal to 12 sine 40, which equals 12 sine 40, oops, 12 sine 40, which equals 7.71. And we know that A is equal to minus 10 meters per second squared. And again, let's think about this journey. This journey goes up and comes back down. So I want to find the time for the entire journey. So let's start there and end there. And for this, delta x is not equal to 2 meters. What is delta x equal to? Minus 2 meters. It's a displacement, and the direction matters critically. 2 meters is up here. And if I write the question correctly, the ball will pass through there. The shadow will pass through there, and you'll get an answer, and you won't think anything of it. If I don't write it correctly, then it's impossible for the shadow ever to get to plus 2 meters, and you'll get the square root of a negative number, and you'll know there's an issue. But if I write the problem correctly, you'll get an answer. It'll be great. It's a wrong answer because it's the wrong visualization. So that is important. That's why diagrams they limit the number of slips you're going to make, because at some point a slip is not a slip; it's a mistake. So and then I want to find my delta t, and I say, well, let's have a look at this. Delta x is equal to vi delta t plus 1/2 a delta t squared. So delta x is minus 2 is equal to vi 7.71 times delta t plus 1/2 times, minus 10 times delta t squared. So let's take this to the other side. Plus 5 delta t squared. Take this to the other side. Minus, I'm going to call that 7.7. I'll get rid of the 1. Delta t minus 2 is equal to 0. Let's double check on that. That's a negative, goes to the other side, becomes a positive. That's a positive, which becomes a negative. Yeah. Quadratic equation. Okay, let's change colour pens. Not the end of the world. I just got to do a bit of remembrance. Delta t is equal to, what is it? Square root of plus or minus b plus or minus the square root of b squared minus 4ac all over 2a. Am I right? Minus b, yeah. Yeah, thanks, yeah. I had a little alarm bell going off in my head, and I'm thinking, oh man, I hope I don't get that wrong in front of all these people, which means, I'm going to get it wrong. Minus b plus or minus the square root of b squared minus 4ac all over 2a. And there's numbers. So I go delta t is equal to minus b. So this is a, and that's b with a negative included, and that's c with a negative included. So minus b is plus 7.7 plus or minus the square root of b squared minus 7.7 squared minus 4 times 5 times minus 2 all over 2 times 5. So I'm going to go way over here. So delta t is equal to plus 7.7 plus or minus the square root of, and this is going to be 7.7 squared, 59.3 plus, because it's minus and a minus, 40 all over 10, which equals plus 7.7 plus or minus the square root of 99.3 over 10, which equals, square root of 100 is 10, I'm going to call it 10. So that would be 17.7 over 10, which equals 1.77 seconds, or it's going to equal minus 2.3 over 10, which is minus 0.23 seconds. Those are my two roots. Which do you think it is? Seems to me the clock started when I started, so I'm going to get my time sometime afterwards. It's that guy. Take that up there. This equals 9.19 times 1.77 equals 9.19 times 1.77 equals 16.3. Yes! So what do you think? Can you see how, if you had called that a positive 2 meters, you'd have had a positive 2 meters for this C, and that would have basically given you a negative 840. You'd have still been able to get the square root of it. So you'd have had the wrong answer. So there is another way, and that is, if you don't like using quadratics, you've got to use physics. So if trying to find delta t gives you a quadratic solution, then the other alternative is that you try to find your VF. So here you'd find VF. So you'd say VF squared equals VI squared plus 2a delta x. Having found your VF, you would say VF equals VI plus a delta t. In the end, you've got to find your delta t. But you can find your delta t using a quadratic on the vertical information. Or you can find VF on the vertical information and then find your delta t using two physics equations rather than one mathematical equation. And frankly, I'll find that some semesters, pretty well everybody's doing the quadratic way, and pretty well other semesters, everybody's doing the VF and delta t way. But they both work. You just got to make your choice and do what you need to do. Okay. I need to make a start on this. We've got a few minutes. So this is simply saying, can't we just do this using ijk vectors? And the answer is yes, we can. The problem is we can't do it for all problems. I don't know how to do the square roots of ijk's and all that kind of stuff. So of these, I tend to be comfortable using that equation, and I tend to be comfortable using that equation, and I'm comfortable using that equation, but certainly not that equation. I'm not going to go near that equation. And we use delta r's rather than delta x's because it's a tradition and all that. And so the two common ones are using VF equals VI plus A delta T, and delta X or delta R equals VI delta T plus a half A delta T squared. I can do those. And all that happens is I get a particle as an initial velocity of that. So there's my VI. And it has an acceleration of that. There's my A. And I want to let this thing happen, so this is going to go off like that somewhere, and I'll get a VF. And my delta t equals 0 seconds, t equals 6 seconds. So there's my visualization. I say VF is equal to VI vector plus A vector times delta t, because they still count. What I should have done was, shame on me, VI is equal to plus 3I minus 2J plus 4K meters per second. And A is equal to minus 2I plus 4J minus 6K meters per second squared. And delta T is equal to 6 seconds, and I want VF. Let's put some little things in here so we know what we're doing. So I go, oh yeah, okay then. VF is equal to VI plus A delta T. And for these I like to use these little grids. And the first thing I want is VI. That's what it says, do VI. So I look on here and I go, oh, that's plus 3 minus 2 plus 4. And then I want A delta T. Delta T is 6 seconds. So I want A multiplied by delta T, which is 2, minus 2 times 6 is minus 12. 4 times 6 is 24. Minus 6 times 6 is minus 36. So I have VI and I have A delta T, and I got to add those together because that's what that operator says. So I got minus 9I plus 22J minus 32K meters per second. And if I look at that, minus I9, oh, did I mess up? I'm sorry? It's E? Oh, good, okay, good. At least you know that I'm not remembering these things. So there's my answer. Just think of what we've done. We've done a projectile motion in 3 dimensions. Really a 3-dimensional constant acceleration motion. It wasn't a projectile because we didn't have the acceleration due to gravity as being 10 in the y direction. But I could do a 3-dimensional projectile by saying the acceleration is 0I minus 10J plus 0K. So this is same skill with I'm taking the IJK skill, I'm taking the 2-dimensional motional skill and just shoving them together. And it works. So what I just did was, so then I can do a problem like this, and I'll leave you to do this. This is just another problem. Let me just flesh this out, because I got 3 minutes, so let me flesh this out. So this is saying I have an initial velocity of that. So here's my initial velocity VI, and it's in projectile motion. So what's my displacement after 3 seconds? This is t equals 0 second. This is t equals 3 seconds. And I say, well, okay, I got VI is equal to plus 5I minus 4J plus 6K meters per second. I got A. Well, A is a projectile. I know it's always going to be pointing downwards. My A is going to be pointing down towards the middle of the earth. That's going to be 0I minus 10J plus 0K. That's my projectile. That's my acceleration vertically for a projectile. Because it's a projectile. It points down towards the center of the earth. And my delta T, of course, is going to equal 3 seconds. So I can say I want to find my delta X. So delta X is equal to VI delta T plus 1/2 A delta T squared. So I have my I, my J, my K. VI times delta T is my VI times 3. So that's going to be plus 15. And this is going to be minus 12. And that's going to be plus 18. You see that? I took VI, which is plus 5I minus 4J plus 6K. And I multiplied it by my time interval. And then I have a half times a times delta t squared. Trust me, of course, I use 3 seconds, so a half of 3 threes are 9, and a half of 9 is 4.5. But still, 45 times 0 is 0, I, and minus 45j plus 0. Okay, let me just go through that again. So this is minus 10 in the y direction, so half of that is 5, minus 5. And the time is 9, so minus 5 times 9 is 45. It's in the y direction. So I've got to add these two guys together. So I get plus 15i. Add these two guys together, minus 57j. Add these two guys together, plus 18k. It's going to be meters. 15, 57, minus 57, and 18 there. These are quite doable. I just can't give you the whole set of problems. Next time we'll do relative velocity. It's easy. Look ahead. And we'll end it there.